Again, folks, here we're going to have a look at how to find a solution to this equation that I've put into OneNote here. I've just realised we're going to have one slight change to that equation to make it worthwhile, and we're going to make that root 3 instead of root 2 there, and we'll find out why that is a little bit soon, a little bit later. Okay, so to do this, what I'm going to do is I'm going to do the working out actually with Graphmatica open in front of me, and the reason for that is that when I've solved this equation here, when I've found the general solution, I want to find all the solutions in this range here. Now, one of the easiest ways of doing that is actually to graph this situation here, graph where root 3 tan bracket 2x plus pi over 3 equals 1, and then use that general solution together with the graph to find these particular solutions. Okay, so let's see how that works in practice. Okay, so let's swap over to Graphmatica here for a moment. I'm just going to clear out what we've had from previous work here, and just going to move that graph a little bit to the right for the moment, and let's write our equation. Just get the tablet in front of me, turn it on, and we're almost ready to go. I hope. Come on, pen, where are you? Alright folks, here we are back again. Just paused the video, wrote a few things here. So what I've done is I've transferred this question over to my screen here in Graphmatica, and I've done the first line of working out a solution, working out a PV. So if you do have a constant in front here, always move that to the other side before trying to take the inverse tan. Okay, so here I've got 1 on the other side, so I've divided by square root 3. So at this stage, to get the PV, we're going to take the inverse tan of this here. Now, when you take the inverse tan of something that involves 1 and root 3, you should be alert to one of those special triangles again. So I'm just going to sketch that out pretty roughly here, but hard to draw it on the tablet. It's meant to be a right angle triangle. So 1, 2, root 3. And that angle there was pi over 6, and this one pi over 3. Now if you look at the tan is opposite over adjacent. The tan of pi over 6 is 1 over root 3. So when I go and find the general solution, rather than grabbing my calculator at this stage and getting a decimal answer, okay, what we're trying to do here is find exact values in this case. So what I can say is that the PV is pi over 6. Let's try and rewrite that. Let's put that back. Pi over 6. Once again, why? Because the tangent of pi over 6 is 1 over root 3, so the inverse tan of 1 over root 3 gives this angle here pi over 6. Alright, so that's all good, and remember that is our PV. Remember, the PV is always the value that you get the moment that you take the inverse tan, or in this case the inverse tan, or for sine and cosine, the inverse sine or cosine. So I haven't written an inverse tan, we don't need to, that's unnecessary. This is perfectly fine to write it like this. Okay, so at this stage I'm not going to try and get x on its own. I'm going to write my general solution, leaving on the left hand side here the 2x plus pi over 3, and the general solution is n pi plus our PV. If you're not sure why that's the general solution, look at the previous video. Now at this stage we now get x on its own, so I'm going to take that pi over 3 to the other side, and if we can, we'll simplify. And can we simplify that? Yes, we can. Pi over 6 minus pi over 3 can be simplified. Pi over 6 minus pi over 3, common denominator would be 6. So that's pi. Not going to change that fraction, hasn't been changed. But this one I'm multiplying top and bottom by 2. So we end up with pi take away 2 pi, which is negative 1 pi. So negative pi over 6. 1/6 take away a third is negative 1/6. So that's negative 1/6 pi. So coming back here, n pi minus pi over 6. Get x on its own. I could divide everything here by 2, but much neater, and I would encourage you to do this as well. Don't divide by 2, instead multiply by a half. And then tidy that up by multiplying this in. So we get a half n pi, or n pi over 2 if you prefer, and a half times pi over 6, that would be pi over 12, so minus pi over 12. So here is our general solution. Okay, so at this stage I'm going to swap completely to Graphmatica. Okay, and why am I using Graphmatica here? As I said before, because it should help us find the particular solutions we want. We wanted the solutions in the question from negative pi to 2 pi. So at this stage, how am I going to do that? Well, I'm going to graph. Let me just move this a little bit out of the way. I'm going to graph two equations. Y equals tan bracket 2x plus pi over 3, and I'm going to graph y equals 1 over root 3. Let's have a look and see what that looks like. So y equals tan bracket 2x plus pi divided by 3, close bracket. Alright, that's that one there. Probably an unfortunate colour, green on green, so I'm just going to try and change that colour. Pick line colour, pick graph colour. Let's go with blue. There we go, it's more easy to see. Okay, and let's graph y equals 1 over root 3. SQRT, I think, for square root. No, let me just pause the video for a sec. Okay, just back to it here. I needed to put brackets around that. If you're not sure what operator to use here, under help you can go to operator table, which is where I went, and I looked up how to get the square root here. So that was under help, operator table. So I can see here I've got a number of solutions. Do I need to change the scale of the graph? No, I think these solutions are actually out of the way of my working here. So I'm going to leave it like this, but let's just highlight the solutions we want. So let me grab the tablet again, and let's use a color that we can see. Let's use red. Okay, so it looks like the nearest solution from negative pi up this way, okay, would be this solution here. I've got another solution here, one there, 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 and there. So we've got 6 solutions we need to find. So let's go through that process. Let's swap back to a different color. Okay, so if I let n equal to 0, what's my first solution? Okay, that would become 0 here, negative pi over 12. Now let's relate that to the graph. Okay, that's this solution here. This is when n equals 0. Remember, well, I'm not sure if you do remember, but the solution we're getting is the one closest to the origin. That will always occur when you make n equals 0, okay, in your general solution here. So that's n equals 0. Now I can see that to get this solution here, I can let n equal -1. And that's the only negative value for n I need to go down to. Hopefully you can see the value of having the graph here, because you know how many negative values for n we need to go and use. So if I make n equal to -1, I get negative a half pi minus pi over 12. So negative pi over 2 minus pi over 12, remembering that negative pi over 2 would be negative 6 pi over 12 minus another 1 pi over 12, so negative 7 pi over 12. Remember what I was doing there was changing that to negative 6 pi over 12. Okay, let's move. This is n equals -1. This will be when n equals 1. So n equal to 1, x would equal, okay, we're going to get pi over 2 minus pi over 12. Okay, pi over 2 minus pi over 12. Well, in this case, this is positive 6 pi over 12. Take away 1, so positive 5 pi over 12. N equal to 2. We've got 3 solutions still to get. So this solution here will be when n equals 2. Okay, so that's going to be a half times 2 is 1, so pi take away pi over 12. Well, that's 12 twelfths, so 12 pi over 12. Take away 1 pi over 12 would be 11 pi over 12. N equal to 3. That's the solution here. So that will be 1.5 pi, or 3 pi over 2. Minus pi over 12. So that's going to be, to multiply top and bottom by 6 here, so 18 pi over 12, take away 1 pi over 12, subtract those two, you get 17 pi over 12, and our final solution, n equal to 4. Okay, a half times 4 is 2, so 2 pi over 12, take away, sorry, 2 pi, let me check that again, half times 4, yes, 2 pi, take away pi over 12. Okay, so that's going to be 24 pi over 12, 24 pi, take away 1 pi would be 23 pi over 12. Alright, okay, we've got our 4 solutions using a bit of technology to help us here. Remember, you can actually graph all this tan stuff also in these trig equations on your graphics calculator. Of course, it's much easier if you've got a wider screen, and in your assessment you're going to be able to use Graphmatica, so I'd encourage you to make use of the technology that you've got access to. Alright, okay, so jump back to OneNote and we'll have a look at some questions I want you to do and what to do after that. Alright, catch you in class.